Hey everybody, Adam Savage in the cave alongside our friend James from Hacksmith. How are you, sir?
Not too bad, how are you?
Very good. Now, every time you come to the cave, you bring some awesome goodies to see, and you reached out and said you were coming to town and you had something, and I'm dying to know what it is.
Yep, so last year I showed you the prototype for liquid oxygen lightsaber.
Yeah.
And this year I'm really excited to show you something because it's something that we're even more proud of.
Yeah, your guys' manufacturing ambitions are like, I learn a lot from them. You guys have a tremendous amount of ambition about making stuff.
It's gone to another level, and I'll get to that shortly. Okay. So I was a Boy Scout back in the day, and I loved Swiss Army knives. I had no idea it would inspire my logo 20 years later, but we set out to create the ultimate everyday carry. Basically, a Swiss Army knife reimagined using modern materials, advanced technologies, and tools that you actually use, because it's 128 years old. Swiss Army knife's been around for a while. Right. And when the design hasn't changed since '61, there's a few things that are missing. So I want to start this little presentation by showing you my old Swiss Army knife.
Sure. Oh, wow. Wait, what happened? Did you ritually destroy this?
We cut it in half.
With the new
With the Smith blade.
What? That is a magnificent narrative passing of the torch. Before we even get into this, I am curious about how you started thinking blue sky. Like, was there a thing from a multi-tool you took as a handle to start with, or did you guys just sit down with a whiteboard and like, what is our dream?
Yeah, so the reason I wanted to do this is I love Leatherman. Yeah. But I've never managed to actually everyday carry one because they're pretty big and bulky. Yeah. And then the keychain ones are not, they don't have that many tools.
My Leatherman started to destroy my car upholstery.
Yeah. So basically that's where the idea began of, could we make an everyday carry that you actually everyday carry, and can we make it useful enough that it's really going to come in clutch when you need to?
So that's a matter of what its qualities are, but also its form factor. Mm-hmm. So you were striving for something that was a sleeker form factor.
Exactly. It weighs 88 grams. A normal Swiss Army knife weighs 100. A Leatherman about 250. It's a titanium body with a frame lock design. So we started with the base knife and shape that we liked. So I've been calling it reverse Tonto. The knife community sometimes is like, it's this or that, and it's like, okay.
Yeah, sure.
And then we just started very blue sky. What tools can we add and what would be useful? The main standout feature of the Smith blade is the integrated bit storage and 4mm driver. And the way it actually works is really quite cool, because you drop the bits in the middle, you push down, and you slide it in, and that's the hexagon.
So those springs don't pressure back, they pressure up?
Yes.
Ish.
There's more to it.
Oh, no. So, sorry, I'll stop jumping ahead.
We came up with this design and 3D printed it. It was super easy. Yeah. And then we asked our manufacturer, one of our manufacturers in China, if it could be machined, and they said no. So Ben, who couldn't make it this weekend, he's our resident CNC expert, and he set out on a quest to figure out how are we going to machine it. And this is machined using 3 different end mills. So a normal end mill, a slotting end mill, and something called a double chamfer tool.
The spring is?
No, the internal hex geometry.
The internal hex geometry. Oh my gosh.
Yeah, so are you familiar with the double chamfer tool?
No.
So.
Oh. Top and bottom?
Exactly.
But
so it's
very
literally
tiny.
It's a thin shaft, and then it's a sideways diamond.
Right.
With 60-degree angles.
But
which means you can drag it in and up and make a perfect hexagon.
And yet the whole thing is less than 100 thou across, it seems like. It's a very small space you're machining into.
Yes.
Oh my God.
Getting that first part was actually relatively easy. The second part, so we actually had a fully functional prototype last summer. This has been about a year in the process.
Okay.
The issue was, before we had the spring, I had basically little silicone a nub that you jam in there to keep the bits from falling out. Right. Because what we found was there is a magnet there, so it sucks in. Yep. But if you make that magnet too strong, it becomes really hard to remove the bits, which isn't a good user experience. And if you drop it,
they fall out.
They fall out. I came up with the idea of the compliant spring. and I used a random scrap piece of spring steel I had in my lab, and I cut it, and I super glued it in, and it worked. And I'm just like, oh, that was easy.
But now it's time to
Cue the next
manufacture
few
that.
weeks of me trying to make it again, and I couldn't. And I started to go crazy. And the problem was I broke the original prototype. So at some point I'm just like, did it actually work? Am I
Am I
going
imagining
crazy?
that I ever got it?
Because even like cutting something like that, I was trying to laser cut it, but the problem is that's a huge heat affected zone, so you're going to kill
and then you lose all the spring
everything.
Yeah.
So we ended up using the Wazer to water jet cut it.
Ah, fair.
And we got it to somewhat work. And maybe it was my ego. I wanted to keep the spring because even though it wasn't working to keep the bits in when you drop it, I couldn't get over how nice it presenting the bit is.
Right.
It's just such a nice fidget experience that also with some practice, you can one-hand it if you're under the car and you know, do that.
No, I appreciate you keeping your attention on the experience. That's
Exactly.
really neat.
So, in a parallel path, Ben was also trying to solve this problem.
All right.
And he came up with a really ingenious solution. So we already have the internal hex geometry.
Yeah.
But if you look close, it actually steps up about 0.1 of a millimeter. So the hex goes like this and goes like that. And then when the magnet grabs
0.1
it,
of a millimeter.
it just holds the ever so slight edge of the lip. And it was funny because he started doing drop tests and the bit stayed in. And he showed the rest of the team. And he was confident that he had solved it. And I was hoping he did. He brought it to me. And in my lab, he gives it to me. I'm like, all right. And I drop it. And the very first time I drop it, the bits fly out. And he's like, what? I pick it up, I put them back in, I drop it again. Bits fly out. Every single time. It's just like, am I super bad luck? Or did something change between here and the other lab? And it was a very, it was the opposite of what you think. So he was testing it on epoxy concrete floors, which you'd think is the worst case scenario because that's a hard impact, right? In my office, it's plywood and linoleum.
And that amount of...
And I think that amount of squish was just enough to change the dynamics that it actually popped out. And we're like, crap, that's not a solution then because most people are going to drop this on their kitchen floor, not a concrete floor.
You're bringing up this moment that would happen on Mythbusters all the time, in which I would say something, right? I'd break out a story and then present it to the team, and I'd be like, "Well, blah blah blah, we're going to drop it on concrete because obviously that's the worst case scenario." And then someone on the crew would be like, "Is it really?" And then I'd be like, "Why are we even discussing this?"
It's got to be.
It would turn out to be absolutely valid.
Yep.
Your assumptions are always to be questioned. Okay, so.
It didn't work on wood.
On the wood floor.
And the spring didn't work enough by itself.
Yeah.
But when we combined the two together, that was enough. Because what the spring is actually doing is it's actually racking the bit. Like if you look close, the bit is actually sitting up. So we're actually tilting it in favor of the
that little
lip.
one sheet of paper thick lip that holds the back of the bit in.
And now you can drop it and the bits don't fall out. Sometimes they will dislodge the magnet just a bit. And if you drop it again, then the bits will fall off.
Okay, yeah.
And I feel like it's a reasonable expectation that if you drop your knife, when you pick it up, you look at it, and you might click it back into place before you put it in your pocket.
So, go ahead. I have so many questions.
So we could talk for another 20 minutes about the bits, so I'm going to do a really concise explanation.
Great.
So, ASTM standard for 4mm bits. The male hex should be between 3.91 and 3.96.
That's a very small window. And in the actual manufacturing
tolerance? And then the female hex is supposed to be 3.99 to 4.04.
Okay.
What we found when we started measuring other manufacturers' bits is a lot of them are 4mm. Some even more than 4mm, which means if you get on the smaller side of the female, it's not going to fit.
Oh, man. Now, it's like Robertson and square drives.
Yeah, and we found ourselves at a fork in the road because at first we didn't want to make our own bits because we need to order these 10,000 of each style at a time.
Of course.
And once we started measuring other bits, we ran into the issue of, okay, well, if iFixit bits are one size, LTT bits are another size, what size do we make our internal hex geometry? We want to make this the best user experience you can have. And the only way we can do that is if we sell our own bits. But that's the part of business I I really don't like making it. You have to buy our bits to make it work.
You don't want to lock them in.
So we wanted to figure out a way so you could bring your own bits.
I appreciate that ethos. I really appreciate that.
We ended up deciding to make our own bits, but we wanted to make them still compatible with as many bits out there as possible.
Gotcha.
So our bit retention works best with our bits because we have the short hexagon shank. Because the thing with 4mm bits is sometimes you'll get ones where the hexagon is almost the whole length of the bit.
Right.
And if you have a tiny Phillips, you're not going to stick it in the hole. It's the most annoying thing ever.
Right. Yes.
So because we ordered our own bits, we were able to have a long shank, and we actually made our bits slightly longer. So standard 4mm bits are about 28 millimeters. Ours are actually 32 because we had enough space to give you just a bit more reach.
And a little more space means it's one more bit of electronics you can actually get to.
Exactly.
Okay.
And now that we have that, is great, and you can use other bits. LTT bits also have a very long shank, so they work pretty good with the bit retention method. Again, ours are probably the best they'll work. But again, it was that fine line of we want everyone's bit to work, but we want our bits to feel nice. So we went with the larger size because the smaller bit will fit, but it'll be a bit loose. Our bits will be nice. Tight. We've got the right angle attachment.
Yeah, I saw that.
So you can get a bit more torque on there, and then you've got the other one at the other end. Oh, sorry. One last thing that you'll get a kick out of. So you'll notice that our bits are laser engraved.
Yep.
Some would say that's the cheaper way of making a 4mm bit because the other method is stamping. Yeah. And stamping looks nicer.
Sure.
But guess what happens when you stamp something?
You change the dimensions of it.
It becomes an oblong hexagon. So as we're measuring across flats, it's just like, okay, well, this flat to this flat is in spec. This flat to this flat is way under spec. Wait a second.
That's
and it was just like, okay, that's another issue.
Yep.
Okay. Enough about the bits. We'll move on to some of the other stuff. So you've got a imperial ruler on this side, and then you've got a metric ruler on this side.
Fabulous.
And on the Pro Edition, the ruler actually continues along the blade, so then you get more measuring space.
Nice.
We got a bubble level.
I love the bubble level. And the bubble level works, does it work like that and like that?
Yep.
Great, amazing.
Yeah, we made sure that everything was recessed.
And it's like not a water in there. It's just something slightly thicker?
I'm not too sure.
Oh, okay.
We don't manufacture that part.
Okay.
On the Founders Edition, tritium. So it'll glow for 15, 20 years. You got a tungsten scribe and glass breaker.
Oh, nice. Oh, wow.
Now,
I see a pry bar.
Yeah, you got your bottle opener, pry bar, and staple puller. It's great for pulling staples. And now the blade. So, you notice it's kind of noisy.
There's a ratchet.
It sounds like a ratchet, but it's not. So we have ceramic bearings, because normally when you're making a nice knife, you try and make it as smooth and as we went the opposite way. So because we were taking the knife apart so many times, and this is a frame lock design, so there's a little ball detent there, and that's what holds the blade shut. Well, what I noticed, because we were taking the knives apart, was the ball detent was actually scribing a perfect radius on the knife. And then I was like, what if I just put more detents on the blade? And now we have a 15-degree protractor.
Wow! Oh, dude. Oh, that's kind of great.
And what I love about it is it doesn't take up any space.
Right.
If you don't know it exists, you just don't know it exists.
Right.
And I love when design can be hidden like that, where it's not, I didn't sacrifice anything to add that.
Yeah.
And the thing I really liked about it is it now has a signature sound, unlike any other pocket knife out there. And when you flick it open, it's...
Right.
And everything from our light edition, which so we have the light edition, 7-in-1, standard, 14-in-1, and Pro, 21-in-1, and all of them have the protractor. So they all sound like that. So, for example, this is a gold light, and it also...
Dude, it's a great...
That's
a great little addition.
Yeah.
And sorry, go ahead.
And we weren't sure if people would like it, but I haven't found a single person who's like, I don't like the noise.
No one minds
yeah.
No one minds that.
So we local to us, actually in Niagara Falls, there's Grimsmo Knives, and he actually runs a YouTube channel, and he does deep dives into the CNC machining of his knives.
Yeah.
And he makes $1,000 knives.
Right.
So we were able to go on a tour of his facility and see the level at which he, the fingernail groove in the final ones will be deeper, so you can grab it there. You can fingernail it from the top.
Gotcha.
But also, if you just use the pad of your thumb to push down on the bit and slide,
now I see what you're.
It pops out. And the fidgetability of this is just so good.
In your pocket. Oh my goodness.
So I showed his team this knife, and they make very expensive knives with incredible tolerances.
Right.
To the point of when they assemble the knives, they have the dowel pins for putting it together in increments of 1 thou. So they're literally matching up the pin to the blade to make it perfect.
Right.
And every single one of them, after a few flicks open, they're like, man, that's really cool. I'm like, all right, if these premium knife makers like this, I think we're on a good track. We've got a file on the back of the blade, and if you want to be a Bond villain, you can.
Excellent. Saw your way out of the
wire stripper.
Oh!
So literally, you just put the wire in there, and then you just put a bit of pressure, spin, and pull.
Oh, that's lovely.
You know where I got the idea from that? Did you know Swiss Army knives have a wire stripper?
Yes, it's in the back of the blade, right? Is it a notch?
It's in the back of the bottle opener.
That's right.
And the funny
I've always
thing is,
looked at it on the list and never actually tried it.
So there's a video on YouTube of this old guy showing you how to use it, and every single comment on that YouTube video is, what?
Yeah.
And it's just like, okay, you guys went a bit far with the hidden design.
Yeah.
But that's where it gave me that, because really it just gives you a place to put the wire to let you then use the blade to twist and pull. On the light, it's actually even better. So you see the descending holes? That's for different wire gauges.
Oh, wow. Oh.
And because it's supported on either side fully, it works so, like if you have a strap of wire,
you just twist,
and just pull. The other thing I really like about this is we have a reversible belt clip, so you can put it here or there.
Gotcha.
In this position, that hole, which is standard house wire, pokes up to the underside of the belt clip, and it's a 10 millimeter perfect strip.
Amazing. Oh, dude.
The level of OCD, I was just like, what if we could make it a round number?
Wow. Oh my God, you must be so excited to see these out into the world.
So,
a flint striker.
In the back, and you can either use the bits or the tweezer.
Oh, wait, tweezer?
Oh, sorry. That was the other best part.
So it just slots right down.
Yeah, and when you look at it, you're like, oh, it's going to fall out. It does not fall out because the tweezers self-retain themselves.
And you guys ended up putting flint right here for a striker. Dude.
Yeah.
I'm just over the moon. That's so yeah. That feels good.
So, since we did all the prototyping in-house,
Yep.
from the start, we were going to make the Founders Editions in-house.
Right.
So, Canadian-made and all that. And then, when we're finalizing like the design and communicating those design changes to our factory in China, we realized, maybe we should just try and do it ourselves. So, the lights are made in China.
Yeah.
And we're actually making the Pro and the Standard and the Founders Edition all in-house. So we got 3 CNC machines right now. We got a few more on their way. And I was even able to use the Carvera, you know, the little desktop CNC?
Yeah.
So I made this nice little display piece.
Look at that!
Where I kept the knife in the picture frame that it was machined out of. And I taped it off, bead blasted that, and installed all the hardware.
Dude.
So it's a nice little airplane safe
I love
thing you
that.
can take around and show people.
Wow. That is so beautiful.
Yeah.
You should totally sell these as a limited edition. This is, I love the saw cut too. That's the best. Oh my God.
So, we're still refining the last few things, but we were able to make one Founders Edition that we finished 2 days ago. That's for you.
No! I was hoping.
You are the very first person outside Hacksmith Industries to get their hands on a Founders Edition.
Dude, oh my gosh. I was secretly hoping. So you never know, right? I know that, manufacturing can be a nightmare and you like so many ducks have to get in a row, but oh my God, you guys must be so excited about the world. Yeah, sorry, I know I'm impatient. Look at that.
So, I put tape.
It smells good.
So, that is your Founders Edition.
You guys.
On the Founders Edition, we have our autographs on the inside, and 2, we're actually engraving the serial number of which one it is.
Thank you.
No problem.
This is, I don't even know where to start, but I've been saying it all along. I have a little tiny manufacturing company. We make bags, and I have some glimpse above the clouds about the difficulties of fulfillment and vendors and multiple parts coming from multiple places. And nothing I have done is 1% of the complications involved in this exercise. And that you did it all with an eye towards the passion of something that you wanted to carry in your pocket, but also manufacture locally. That's beautiful.
Yeah, it's always like the best things are when you're solving a problem that you actually have.
Yeah.
And that's something that I feel like big companies, it's very easy to lose, because as soon as you're beholden to shareholder expectations and things, it's like, is the design done? It's like, I guess so.
Yeah.
And that actually still has been a pain point for us, because we're like, we really need to start selling
Totally,
these.
of course.
But I want it to be like, I want the first one to be as good as it can be, and I'm fairly confident that we're there. I already have plans for the next version and the next version, but for now.
Late stage capitalism would lead us to believe that you cannot make a profit with passion over the long haul. And the answer in the small business model is you can. You just have to pay attention to the right things. And I'm so glad you guys are paying attention to the right things.
So yeah, this is available on Kickstarter now, and we're making them in-house, which is going to be an adventure.
Incredible.
And depending on how well the Kickstarter goes, it's either going to become a headache figuring out how to really mass produce these, because right now it's about 2 hours of CNC time per knife, which means, assuming no fails, no quality defects, that's only 12 Smith blades a day per machine. And if we sell 10,000,
sometimes Kickstarter success is the biggest problem you could have.
But the plan is to get more CNC machines, and the real reason that we want to do it in-house is it means we'll be able to launch products like this so much faster.
Oh, right.
Because iterating changes, and already I had a super silly, easy idea. The Smith Blade XL. You make it a little wider. You fit 6 bits in there.
Yes.
You've potentially got room for built-in scissors, maybe pliers.
We'll see. Scissors are the other one that's one of my deal breakers. I love scissors in a device.
So I've also got a Smith Blade Light for you.
Oh,
and
what?
It's not quite orange, but it's gold, so I figured close enough. So we had 3,000 of these made by our factory in China. We've had them since December. Because that's when we were hoping to launch the Smith Blade.
Of course it was.
And that didn't happen. No. So we've held on to them until now. But the idea is we wanted to make sure that we had a Smith Blade for everyone. And if you can't afford the Pro, you can afford something.
Another great ethos, of course, making so that if you want to join in the fun, you can. And they're substantively different. God, this is great.
One last cool thing.
What are you, Steve Jobs?
So we standardized the T8 screws.
Yeah.
Originally it was T8 and T6, and that was annoying.
Okay.
But we found ourselves with a little conundrum because the belt clip is replaceable.
Right.
But unless you have a T8 screwdriver, you're not going to be able to service your knife.
Ah, yes.
So I'm going to do the math on this, but imagine for me for a second, how many 1/4-inch Allen keys are in landfills thanks to IKEA?
Yeah.
Probably like literal metric tons.
I would, absolutely, you're right.
And we have the problem of selling scissors inside of a package that needs scissors to open.
Yeah, right? Yeah.
So what do? We can get these bits made fairly inexpensively, so we can get a T8 bit. Mm-hmm. But again, unless you have 2 Smith blades, you can't do anything. So what I'm actually doing is we're using the Formlabs Fuse to 3D print a little bit flag.
That goes to your T8 bit and allows you to service
but it's better than that.
Okay.
So I had a product that included an Allen key that had a torque on it. And it's actually kind of like a compliant...
Right.
It's a curved piece of plastic. And when you bend, or when you apply torque, when the plastic straightens, that's a torque value.
Oh.
So I actually prototyped my little cheap 1 gram piece of plastic with a curve in it. And
so that we know you're assembling your knife to spec.
It tightens to 5-inch pounds.
That's really cool.
So many little details in this that will make the inner engineer really, really geek out. And yeah.
Congratulations. Just amazing.